So in this problem, you're given an array and you have to print all the sums for each subarray of size 3. How would you code this? So your first thought, if you don't know a sliding window, would be to just like take these three, get the sum, print it, and take the next three, sum them and print it, and take the next three, sum them and print it. So what this would look like in a video would be like you start at an index, you add up the 3, you sum it, then go to the next one, you add up the 3, sum it, then go to the next one, add up the 3 and sum it. So this is not the most efficient way to tackle this problem, and a more efficient way is sliding window. So that
why isn't it efficient?
Or it is efficient.
No, I mean,
but,
can you explain why it's inefficient?
Oh, you're right. Sorry. So it's inefficient because it's a double for loop. One for loop is going through each index. So here, this is like the first index, and then this is the second index. And each time it's going like a number of times it has to go and add things up. For example, in the example we had on the first slide, the size was 3. So for each iteration, we have to do 3 additions and then compare. So that can scale up really fast. For example, if the size was 100, and for each iteration, you have to do 100 additions just to find what the sum is. So instead of doing these 3 additions or 100 additions, you can use a sliding window method where you have like a window. So this window is the length. So in the beginning, our problem, the length of each subarray was 3. So because the length of each subarray was 3, we had to add up 3 for each time. And wait, I need a second to think, sorry.
Okay, to just follow him while Kanishka isn't talking, the reason that the sliding window method is a lot more efficient than the brute force method is because in the brute force method, you're constantly going back to values that you already reviewed in the past, and the sliding window technique that Kanishka is going to explain, with the sliding window technique, you won't actually need to go through each value again, like multiple times. So if you remember from the brute force method, we were going over the same values like I think like twice. And as a result, it's inefficient, and some contests will require you have like a fast solution to that kind of problem. And a naive brute force method will not be good enough. So we have to go with the sliding window technique that Kanishka will explain.
Yeah. So instead of adding the 3 in each iteration, what we can do is subtract the leftmost one and add the rightmost one. So in here, it is simply, as you can see, it's just going to shift the window to the right each time, checking the sum. And rather than, or actually, let me just explain this to you through code. So imagine we wanted to code this. One way of doing so would be, let's say we have an array, and let's just give it some random values. And we want to print out the sums of every 3 in it. So now you've, like the brute force way, would be a double for loop where the first for loop would like go to each index I, like it would go to 1, 2, 3, and at each index, it would sum up the 3 values, sum up the 3 values, and sum up the 3 values, and then print them. So that's a double for loop, and that's like approaching n squared complexity, which is what we don't want that. So instead, what you can do is let's say we calculated the sum for the first three, and now we want the sum for the next three. So
You could just subtract the first element and then add the next one.
exactly,
right?
exactly. So 1, 2, 3, and 2, 3, 5, the only difference is you can subtract 1 and add 5. So that saves a lot of operations. And so instead of the 3 addition operations you would do in like a brute force way, you only have to do 2, a subtraction and an addition. And that 2 stays constant no matter how big your window gets. So if your window is a size 100, then instead of 100 additions, you're just doing 1 addition and 1 subtraction.
Does everybody get that? Can I just do a really quick visualization?
Yes.
Okay. So here you can just see we have this array of 7 numbers. Basically, if we want to find the sum of all subarrays of size 3, we initially start off with this subarray over here, numbers 1, 2, 3. And we calculate that sum to be 6. Now we want the sum of the next subarray, which is from 2 to 4. But what you see is instead of recalculating, instead of adding again 0 plus 2 plus 3 plus 4, we see that the difference between this window over here and the first one is that this second one does not have 1. So it does not have 1, but it does have 4. We just added 4. So what the sliding window technique does is take this window, starts it off at the beginning of your array, and slides it across your array like this. And each time it adds a new element, so we'll add a 4, and it will drop the first element, so it'll drop a 1. And that's why the time complexity is better.
Okay. So now, okay. So now I'm just gonna do this code in a sliding window way. So first, we'll need one variable to like keep a sum throughout. So in sum is equal to 0. And then we'll just do a for loop that will, and here, our I variable, that'll keep track of the head index of the window. So because our window is of size 3, I is going to be on the rightmost value. So it's going to represent this 3, for example, in this first window. So we're just going to do int I is equal to 0, I is less than r dot length I plus plus. And for each one, first we're going to do sum plus equals r at I. So we're adding the frontmost value to sum. And then in the beginning, we don't have 3 numbers in sum. So we need to first have a condition that filters out those first 3. So we'll just do if I is greater than equal to n minus 1, then we'll do the rest. So here, or actually currently our n is 3. So basically what it's saying is it's going to start subtracting the leftmost value after the index of I, the frontmost value, is greater than or equal to 2. So as soon as I reaches this point, we have a window of size 3, and that's when we can start printing. So as soon as the window is size 3, we do system.out.println the sum. So that's printed the sum. And then we want to subtract out the leftmost in the window of length 3. So we can do sum minus equals and r at I minus. So because I is the front one, and to get to the first index in the window, you need to go 2 spaces back. It would be I minus 2, which is the same as this value over here. And this can be generalized, but for now, I'm just hard coding the values. And I think that should work. Do you see any problems?
I think it works.
So as you can see, we've printed all the sums of like every 3-unit subarray. So if we wanted to say find the maximum in here, all we would need to do is like keep a max sum variable outside and then just update it throughout the loop instead of printing. So that's a fixed window, sliding window problem. And then the next type is the resizing one. So in here, let me pull up this. So there is like one condition where the window increases in size, and then for some other condition, the window decreases in size from the left. So these conditions, they will vary based on what problem you're doing. And maybe Madhu, do you want to talk about this slide?
Yeah, okay. So an indication that you kind of need to do a sliding window algorithm in a problem is there's a few keywords. So like contiguous, which kind of means like a subarray. So if you go to like one of the slides with an array in it, typically when this is like contiguous, it means like it's like grouped up like a subarray, like the way Kanishka is highlighting them. So that means like the numbers are next to each other. It's not going to be like separated. So that's kind of typically when you're going to do a sliding window problem. And what Kanishka's talked about, where you try to calculate like the max sum within that array of given length subarrays, that would be an example of using a sliding window approach. And then there's one more method where you need to use sliding window, but I'll cover that later.
Okay, so now I'm going to give an example of a problem where you need a resizing sliding window. And it's this problem where you're given an array of numbers and you need to print the size of the smallest subarray with a sum greater than or equal to k. So you get an array of numbers and you need like the smallest length subarray whose like all of them add up to greater than or equal to k. For example, here k is 8. So the smallest length subarray would just be 1, since one value adds up to greater than or equal to k. And now I'm going to be solving this problem in lead code, but you guys can just solve this in your editor. And if you have a lead code account, if you don't have one, I would suggest making one, or you can also just solve this in your editor. And I will post this problem link in the chat. So this is the same problem that I just discussed. Does anyone not understand the problem? And or why we need to use like a resizing sliding window rather than a fixed sliding window like before?
To clarify some confusion people might have, the value k is like it's a given value. So that's typically what you're going to input. So k is not always going to be the same. So in this case, k was 8.
Okay, so if there's no questions, I'll start coding this. So that's just the same problem. And here we get we have to write a function where we get an input of an array. And like on this slide, we call it k. Here it's s. And we have to find the smallest subarray whose sum is at least s. So like in the other problem, we first need to have like a variable that stores the minimum length of the subarray. So let's call that min_len. And let's store that to like a really big number, like 2 billion. Or wait, I should be
You could do
good.
integer.max value.
Yeah, that's the good way to code. And then we also should have a variable to keep track of like the running sum of the window. So we can have a sum variable. And this time, the window's length is changing. So we need another variable to keep track of, or we can keep track of it two ways. One way, we can keep track of the leftmost index of the subarray, or we can keep track of the length of the subarray. This time, I'm going to keep track of the leftmost index of the window. So I'm going to call this left, and it's going to start out as 0. So now we're just going to do the for loop where we go through every number in nums. And just like before, where we did sum plus equals r at I, we're going to do the same thing as the beginning. We're going to do sum plus equals nums at I. And now this is our condition where we expand to the right, like we saw in the video. We're currently, like our I, okay, yeah, let me clarify. Our I is the index of the rightmost part of the sliding window, and left is the index of the leftmost part of the sliding window. So for example, if the window in this problem was 3, 1, 2, 4, I would be at 4 or index 0, 1, 2, 3, 4, and left would be at index 1. So left is referring to the leftmost index of the window, and I is referring to the rightmost index. So when we're adding nums at I to the sum, we're increasing the window. We're adding one more number to right of the window. So like we're adding like one more number. So that's how we're expanding to the right. But what if we want to take away numbers from the left? To do that, we're going to run a while loop while the sum is greater than or equal to s. So what that means is while the sum is bigger than the minimum sum we want, it's going to run this. And if the sum is less than the minimum sum we want, it's going to skip this whole block, go to the next iteration of the for loop, and add the next number in the array. So this only runs after we've hit the sum. So now we want to find the minimum length. So first we need to check, we need to update minlen. So we can do minlen is equal to math.min of either minlen or, and now we want the length of our window. And remember, I is the rightmost index of the window and left is the leftmost index. So the length of our window would be I minus left and plus 1, because these are indexes. So like if this was 0 and 1 is index 2, we would do 2 minus 0 is 2, and we have to add 1 to get the actual length. So this is the length of the window, and this is like minlen, so like global minlen. So now we've updated minlen if it needs to be updated, if we've found a new lower minimum length for that sum. And now we're going to subtract 1 from the left side of the window. So to do that, we do sum minus equals, and what's the pointer that points to the leftmost index of the array?
Left.
Exactly. So I subtract the value at the leftmost pointer, and I do left plus plus. So what I've done is taken out the leftmost value and made that pointer increment by 1 so that it's no longer part of the window. So after this for loop, we've set minlen as the minimum length of the value, or the minimum length subarray that's at least S. So after that, all we need to do is return minlen. So this should work for this test case. Oh, wait. Oh, I forgot to capitalize minlen. I made that same mistake before. So yeah, that's how you do it, and runtime 0ms. Do you have anything else to say?
No, I think it's good.
And for this problem, it asks if there isn't one, return 0 instead. So we can just do like a quick if else. So if minlen, so what would minlen have to equal if it was never updated? It would have to equal to integer.max value. So we can just paste that in. If minlen is equal to integer.max value, and we just return 0, else we return minlen.
To add on to why we're using integer.max value in the beginning is because if we just do minlen equals 0, if you happen to have like negative numbers, then your minlen value is going to get messed up a little right off the start. So that's why you want to do like the highest value possible, so that your minlen is like it'll work out fine.
Also to clarify, this solution wouldn't work if there were negative numbers inside the array. And we just said max value, so, or yeah, if there were negative numbers as well, it would be a much more complex solution, which I encourage you guys to try out. And I'm just gonna post a link to like a bunch of problems in LeetCode, which you can try after this meeting. So now, Madhu, you have a question that you want to go over?
Oh yeah. Okay.
I just wanted to add really quickly, that was a really great explanation. This technique is also commonly referred to as two pointers because you have a left pointer and then your eye is kind of acting like your right pointer. So that's another name for it.
Yeah, and if you guys want to work on some two-pointer problems, you can go to LeetCode Explorer, and they have this Arrays 101 Explorer card. It has a lot of great like two-pointer problems, like mountain array or like move zeros, that are like really helpful for like beginners and everyone.
Okay, Kanesh, you need to stop sharing your screen when you're done, so that I can.
Okay.
Right. So for the last problem of the semester, I think. I don't think we're having. Wait, is this the last meeting for the semester? I don't remember. Anyways, so for this problem, you're given a string, and like just pretend that there are no spaces here. So 1 second, I'll just fix that real quick. They're given a string, and then we need to print the size of the largest subarray consisting of k unique characters, and then obviously k is the value that'll be inputted to us. So I'm just gonna put the spaces back so that it'll be easier to read the string. So the reason this is a sliding window problem is because you're looking at subarrays. So it's usually an indicator that you're going to have to do a sliding window approach to this kind of problem. So to kind of go over, we first want to think about how we're going to code our solution. So we obviously need to come up with their logic. So going based off the sliding window approach, which I'll just go over right here. So first, my window is going to have like 0 units in the beginning. Then I'm going to take the A. So now I have one unique character, which is less than or equal to the 2 unique characters that's the constraint. So since I'm passing the constraint, I'm going to add in the next value. So now I have a length of 2, and that length of 2 is going to override my maximum, which was 1 initially. And I only have one unique character, so I'm still going to go into the next iteration because I am still passing the constraint where I must have 2 or less unique characters. So now that I have 3, it's a bit same as the previous iteration. I have my length of 3 is going to override the maximum of 2. And then there's still one unique character, so we don't need to worry about that yet. So now we have 3 different, we have a length of 4, and we have 2 different characters. And since there's 2 characters, we still don't have to worry about the fact that we need to change a window, because there's only 2 characters and the constraint is less than or equal to 2. And then the next iteration, the length of 5 is going to override my maximum, like all the other iterations. And there's still only 2 unique characters, so we don't need to worry about that constraint yet. And then when I increase my window size by 1 more, we get like a big error that we're going past the unique character limit, because we now have 3 unique characters. So what we need to do is we need to move the left of our window, and we need to start bringing it towards the right. So to show what that would look like is I would take my my far left part of the window, and I would move it over by 1. And then I'll run this check again. There's 3 unique characters, so we need to further decrease our window. And then I do that here. Still need to decrease our window because we're not passing that constraint where we must have 2 unique characters. And then I would go here, and then we're passing the constraint where we have 2 unique characters. So now we're going to move our window to the right more. So the left part will stay the same, and I'll increase my window size. But now I run into the same issue, and then I assume I explained it pretty well here. It's just going to be the same thing all the way towards the end.
Yep.
And then I'd ultimately return my maximum value of 5. So how can we track the amount of unique characters there are and the number of unique characters? The number of unique characters. Does anyone have an idea? It's we kind of went over this concept maybe a few months ago, so I'm not sure if it'll be fresh. But if no one has an answer, oh, someone does. Yeah, a hash set is correct. Well, a hash map, because what you want to do is a hash map will, a hash set could work too. You can do either of them, but yeah, that's the right approach to this problem. So to show what that would look like, let me open up my IDE. Okay. So I wrote down the string that we're using in the problem, and then I wrote the value of k that we're using. And then, you can see my IDE, right? My Eclipse. Okay.
Yeah.
Yeah. So Kanish, like Kanish talked before, we need a left pointer and we need a right pointer. So what I'm gonna do is I'm gonna create my left pointer. So the start of the window, which is gonna be the far left pointer. And then we're also going to have an int for the maximum length. And the maximum length of any, like the lowest possible max length you can get is 0. That's why I'm going to initialize it as 0. And I initialize the window start as 0 because the very first index, or the very beginning of an array, has an index of 0. And then what we need to do is we need to create our hash map. And we want to do a character on the left and an integer on the right, because we're looking at characters, like the unique amount of characters. And we want to do integer on the right because I want to know how many of those characters there are. Oh, shit, I did not spell it right. Okay. And then what I'm going to do is I'm going to loop through the array. So this is what this for loop is for. So yeah, so basically I started my my variable at 0 because indexes start at 0. And then I'm going to go all the way up to the length of the string, and I'm going to increment my my variable by 1 every time. So what I want to do is I want to take, so just like how just like how Kanishk was adding the value of the next index with like the sum plus equals the index, I'm going to do something a bit different because I'm working with characters here. So I'm going to take in the input character, right car, and then. So what this does is it'll take in the very next character that's in the string. And then now that I got that character, I want to put it into my hash map. So the way I will do this is I will, Eclipse is really bad with autofill sometimes. So I'm gonna put in the new character I had just got in, and then I put in my character, and now I need to know how many of that character is there. So what I need to do is I need to retrieve the value of that character. So I'm gonna go into my hash map, and I'm gonna retrieve the value of the amount of instances that character is seen. So what this method does is, 1 second, I'll explain it in a second. So they're not. Oh. Okay. So what getter default does is that it'll retrieve the value of that character I'm searching for. So I'm searching for right character, like the character we just read in. And if we don't find that right character in that hash map, it's going to return to us a value of 0. Otherwise, it's going to return the value of that character, which is the amount of instances that we've seen it in the string. And just like how Kanishka was talking about earlier, we need to have a condition for when we pass that constraint. So in this problem, the constraint is that there's 2 unique characters maximum, or k unique characters maximum. So we need to check for that instance. So if you look at the size of the hash map, we're trying to hold in 2 characters at once. So once the size of that hash map is like greater than k, then we're not passing that constraint at all. And the next thing we want to do is we want to take our very left pointer and we want to move it 1 inside. So I hope you remember when I was showing earlier on the Google Slides that we would take our left pointer and we would move it down 1. So we would want to retrieve the value of the character that's at the very beginning of the sliding window. And then once we get our value, once we get the character from the very beginning, we want to subtract we want to remove it from the hash map, like 1 instance of it from the hash map. So just like how Kanishk was removing or like deleting the sum by the very beginning value, I'm going to remove this from the hash map. Oh, it keeps going to compute. Okay. And then what I'm going to do is I'm going to get to the value of this character that's at the far left, and then I'm going to subtract it by 1. Because I don't want to completely remove the character from the hash map. Because like, for instance, if I have like 4 A's and I want to remove 1 A, I don't want to delete the A from the hash map. I want to just delete 1 instance of it. So what this means is that I'm going to have 3 A's then afterwards, if that makes sense. And that's what this does. So at the left, at the hash map, it's going to search for the character in the very beginning of the sliding window. And then it's going to get the value of that character, which is the integer, and it's going to subtract that value by 1. And it's going to put it into the hash map. So, and then we also need to check for like what happens if the value of that character ends up being 0. It's like, for example, if you run out of A's. So what I'm going to do is I'm going to go back into the hash map, and then I'm going to get the value of the character in the beginning of the sliding window. I'm going to check if it's 0. And if it's 0, I want to remove it from the hash map completely. Because if I don't, this check right here, it's going to put me in an infinite loop. So I need to make sure I remove that value from the hash map. And then what I need to do is I want to move my beginner pointer. I want to move it down by 1. So this is what this is going to do. I probably used some very bad variable names. I'll fix that next time. And then I want to I need to return the maximum length. So this is what I'm gonna do right here is I'm gonna change the value of max length if the length is greater than the current max length. So math.max, and then I want to compare the max length, and then just like how Kanishk was doing, like max minus min plus 1, I'm gonna do the same thing right here. And then at the very end, I'm gonna print out my max length. And then I'm gonna run my program. Hopefully it works. Yeah, we got 5. Any questions? I feel like I didn't explain it the best way, so.
No, that was really good.
Okay.
Yeah, are there any questions?
Yeah, that should be it for the meeting.
All right, I just wanted to cover one more thing really quickly.
Okay.
It's called Kadane's algorithm. It has a fancy name, but all it is just finding the maximum sum of a subarray in an array. So you guys can see my screen, right?
Yeah.
Okay, I'll just go ahead and delete that. So basically in this, this is a kind of popular problem. We have an array and we want to find the maximum subarray sum. So in this case, the maximum subarray sum is going to be 13 because 3 plus 6 plus 4 is 13, right? Everybody sees that? So you may think that, okay, well, for this problem, maybe I just add only positive numbers that are clumped together. So I'd only consider the 1, and I'd only consider 3, 6, and 4, not the negative numbers, because obviously negative numbers bring down your total sum. But what if I put a 9 on the other side of this negative 10? In this case, the maximum sum would be the sum of these 5 numbers, including the negative 10, because 3 plus 6 plus 4 would give us 13. 13 minus, wait, 1 minute. Okay, wait, this is not the best example. Let me make this 12 or something. Yeah, so in this case, this would be the answer for the problem. You may want to include negative numbers if continuing forward gives you even bigger numbers when you add stuff together. So to actually code this, we have 2 variables. We'll have our answer. So that'll start off at 0. And we'll have the maximum sum so far. So max so far, and that'll be 0 as well. We go through the array. So we'll say for int I in array. We will add this I. So this is a for each loop. We'll just add this I to our max so far. And here's what we're going to check. If this is negative, do we want to count this in our answer? Do we want to count negative numbers in our answer for trying to find a maximum sum?
Most likely not.
Yeah, most likely not, because it's going to decrease your sum. So that's why over here, what we're going to do is say if max so far is less than 0, then we're just going to set it equal to 0. Because if it's negative, we don't want to add positive numbers to a negative number. It's better to have 3 than have negative 2 plus 3. You guys get that, right? So that's all this is doing over here. And now to actually calculate our answer, we just say answer equals math.max answer. So it's going to be the maximum of itself and max so far. And then in the end, we can just go ahead and print this out. And that will give us the maximum subarray sum, which you can see is 15 because it's going to be these 5 numbers. Let's say I added a -1 over here. That's going to be 15. It's still going to be 15. Oh, wait, I didn't save this. If I add a -1, you'll see it become 14 and so on. So are there any questions about this? We just have the maximum variable. We have our answer, and then we add numbers. If the maximum so far, which is our running sum, becomes negative, we'll just set it back to 0. We reset it. We just continue taking the maximum of every running sum we've seen so far.
So this assumes that there's a positive number in the array.
Yeah, that's a good question. That this does assume that if there isn't, you could just have a Boolean variable and check if the array is all negatives. If it's all negatives, you can keep track of the largest number and then return that.
Okay.
For that, we could maybe have something like bool. Wait, no, never mind. Well, yeah, yeah. So that's the end of today's meeting. I think it was shorter than the other ones, and I hope you guys learned a lot. Sliding window is a pretty powerful technique for solving a lot of problems, and it comes up in contests like USACO. We'll decide if there will be a meeting next week, and we'll let you know on Remind in Google Classroom. But until then, uh, bye. Thank you for coming.